Okay, so looking at this first piecewise function. So this piecewise function consists of parts of two lines. This is a line, so if you were to see y equals 2x, you know that's a line. If you were to see y equals 0, you know that's a line. So this piecewise function consists of two lines. The first line only exists to the left of the y-axis. It's only for x values that are less than 0. So it is basically an array that starts on the y-axis and goes left. Now this is a line. It's actually a horizontal line. And it is only for x values that are greater than or equal to 0. So if we kind of envision this, it kind of looks like this. Instead of the whole y equals 2x, it's just the part on the left side. Okay? Instead of the whole equals 0, it's just the part on the right side. So this is kind of what this looks like. One little ray going this way, one little ray going that way. And they actually, this one does. Now they don't have to connect at the same place, but this one actually does. Okay, what we're going to do first is just evaluate these piecewise functions. So they give us two values for x. If we plugged in -8, what would we get out? If we plugged in 5, what would we get out? So when you're looking at a piecewise function and they give you a value for x, you have to decide. Does x equals -8, is that part of the top piece or is it part of the bottom piece? Where does -8 fall? Well, -8 is less than 0. So a value of where x is -8, you would plug into the top function. And we would do 2 times -8 is -16. Now the second value is for x equals 5. 5 falls into this interval where x is greater than or equal to 0. So the 5 gets plugged into this function. But there's no place to plug it in. That's because this is a horizontal line. Every y value on this actual ray, once it gets restricted, is 0. There's no place to plug in the 5. The answer is 0. If you guys have your workbooks, you can work along with me. If you don't, you can either watch or take notes. And Ainsley, if you would like your Monopoly game, or whatever's left of it,
I keep forgetting. I'm so sorry.
you are welcome to take that, but I'm probably going to toss it pretty soon.
Okay,
What
I'm really
Monopoly?
sorry. I forget.
I know.
What Monopoly game?
It was for the Four Travelers project.
Oh. Oh yeah. We did Facebook profile.
Okay. Now, number 2. When we look at this piecewise function, the top function is a line, and once we restrict it, it's a ray. The middle piece is a parabola, so it's going to be parts of a parabola once we restrict it. And the last line of this piecewise function is also a line. It's a horizontal line, y equals 6, but it's only for values of x greater than 8. Now guys, I honestly, even at my age and after teaching math just a few years, like 20, I still, in my brain, have to swap this around. I'm a person who likes to have that variable coming first. I mean, they have the exact same meaning, but for me, to make my brain understand, I have to think about it this way. I don't know about you. Maybe you're good either way. Okay, so that is this function g of x. The first thing we're to do is evaluate that function where x has a value of -8. Do I plug that into the top, the middle, or the bottom function? Piece of the function. The top. So it's 2 minus -8 is 10. Okay, now I'm going to evaluate function g where x has a value of 5.
So that'll be the
The top, middle, or the bottom?
middle. No, it's the bottom one.
That's
It's
the top
both.
one.
It's both top.
Wait.
It's both middle and
It's
bottom.
the top because it's equal.
It's the top one
Oh, I'm
because of the equal to. It's the top one because of the equal to. So we'll have to do it again. But this time it's 2 minus 5. So it is -3. Okay, so I would like you to try 3 and 4. You're going to evaluate h for -8 and h of 5, k of -8, and k of 5. So the first thing you have to do is determine which piece of this function does this value of x fall within the interval, and evaluate it for that, and see what you get out.
Wait, will we ever have ones that we use 3 equations for?
Only if I ask you to evaluate 3 different ones.
Oh, like 3 different x's?
Mm-hmm.
Oh, okay.
Yeah.
You have a book? You carry it in your bag?
Yes, I carry everything.
I carry one binder in my bag.
That's just you, honey. I don't care.
That woke me up for a second.
Out of nowhere with the arcade.
Nope, go
No,
straight.
I prefer the creek garage.
Where is this conversation going?
Yeah, I mean, you can be talking about wrestling all day.
You watch it?
All the time.
I don't watch TV.
It's good for you, Jordan. I don't care.
Oh.
No, you did it wrong.
I did it right, I shouldn't have stopped 5 so I should 7 minus 5.
All right. How did you do?
Yeah, I can
You
do
did
that.
Yeah, but I got every single one except that last.
I just didn't, do I have to write them out? Like, each thing out? Cause I just like I literally just like,
What?
alright.
Any questions? Yes, ma'am.
How do you know, like, which one to use?
Okay, so -8. Does -8 fall in this interval, or that interval?
The top.
It's the top one, because this is for x values that are less than or equal to -8. So for -8, I had to plug it into this. Now 5 is this interval. X values that are greater than or equal to 5. So it had to go in here. So you have to look at the interval to determine where to plug it in. Okay. Now, I could have also written this in interval notation from negative infinity to negative 5. From negative 5 to 1. From 1 to infinity. Which do you like better? Interval or inequality?
Inequality.
Inequality? Overwhelming. Okay. Yes, Jack?
You're just gonna be on
How did you do a K of 5?
Okay, so K of 5 fits in this interval.
Like
So you plug the 5 in. 7 minus 5 halves is 14 halves minus 5 halves, which is 9 halves, or 4.5. All right. Other questions? There's no twist to evaluating. It's quite simple. Okay, so part 2 of today's lesson is graphing the piecewise function. So we know we're not graphing the entire function. We're only graphing a piece of it.
So we just graph a piece.
Okay, so we're going to talk about the 2 ways you can do that. The first one is to just kind of contemplate, what does that restriction on the x value mean? X values that are less than 0 have to just be this side, right? So we could just think about this first one, y equals negative x plus 1, and go, ooh, that's a line. It has a y-intercept of 1. It has a negative 1 slope, which means down 1, right 1, or up 1, left 1. But because I can only go to the left, I can only do, okay? Now, before I draw this in, I want to notice that this is for x values that are less than 0. This is the one that includes 0. So can this piece of a function have a solid closed dot here? No, it has to be an open dot because it cannot equal 0. So that dot right there is to be open. And we go this way. Okay, now the second one is also a line. Y equals x is a line. And this line is to the right side. So y equals x is this diagonal line right here. And this time it can equal 0. So we're good. And this one's going right.
What?
So the first one had to go left because it's x values that are less than 0. And the second one goes right because it's x values that are greater than or equal to 0. So, kind of a shortcut for that. Which way is that arrow pointing? Left. So if your variable comes first, your inequality gives you a hint. Right. It's pointing right. It's pointing left. So if your variable comes first, your inequality gives you a hint. Okay, number 2. If we think about that first piece, y equals negative 1, that is a horizontal line at negative 1. But we don't get to do all of it. We only get to do part of it. Okay? So, it's right here, but it has to be for x values that are less than 1. Well, this is where x is 1, so it's only this side of that line. It gives us this ray. Okay, the next one is a line also, but it has a restriction, which turns it into a ray. It is for x values that are greater than or equal to 1. Now, that means I can't really plot the y-intercept. So what we want to do is take the value where I get to start, 1, and evaluate it. If I plugged in 1, where do I start? 1 times 2 is 2.
Minus 2 is 0.
Minus 2 is 0. So I get to start at the point 1, 0. And then this is a line, so I just do the slope. Up 2 over 1. Up 2 over 1. And because it's x values that are greater than 1, I'm allowed to go right.
Gotcha.
Alright, this next one I'm going to do, we'll do pink for the middle one. We'll do green for the top one. And we'll do blue for the bottom piece. There we go. So, the actual graph is all three of them together. But I'm going to do them in different colors so you can see what's going on. So in this one, I gave you an interval, not an inequality. But this means the same thing as x is less than -2, doesn't it? So this is a line, but this line has a starting point where x is -2, and it goes left. Negative infinity is to the left. So if I plug in -2, the starting point for this part of the line, -2 plus 3 is 1. It starts at -2, 1, open circle, because it's not a bracket. All right, now this line has to go left, and the slope is +1. So instead of up 1, right 1, up 1, right 1, we have to go down 1 and left 1, down 1 and left 1. We have to go in the opposite direction. And this, once again, is an open circle because it does not include the -2. Now, what type of function is that middle one? What does it represent? Step function. Okay? That first step gets shifted left 2. It is a rounding down, so it's solid right to open. Solid right to open. Solid right to open. Solid right to open. Stop. Why do I stop right there?
Oh, that's your restriction.
Because that's my restriction. So I got to start at -2 and I got to stop there. Now, can you see that this is truly a function? Because right here, there is no overlap because this is open and that is closed. It passes the vertical line test. Let's see if it continues to do so. This last one is a parabola, but it's not the whole thing. We don't even get to go to the vertex, which would be right there, do we? We can only go for x values that are greater than or equal to 2. So I have to find a starting point. If I plugged in 2, 2 squared is 4. So really, instead of starting at the vertex, I start at the move over 2, up 4. The next move would be over 3, up 9. So really, we're just kind of faking it and doing a curvy up that way. Okay. All right, we're going to do one more together, and then I'm going to give you a chance to work on your homework, which is out of the book. It's just 6 problems, so maybe you'll get a chance to finish. We're going to do this one together, really because of this cool function right here. What kind of function is that middle one?
A square root.
A square root. Now, this square root has a starting point and a stopping point. So I'm going to show you in just a second how to deal with that. All right, so this is a line, this is a square root, that is a parabola. So this piecewise is made up of pieces of 3 different functions. So the first one is a line. We can figure out where the end point of this line is to create our ray. If we plug in the -3, -1/3 times -3 is positive 1. 1 minus 2 is negative 1. So this ray has an endpoint at 3, negative 1. Would that be a closed dot or an open? Open, because it does not include the x value of negative 3. That's negative 1, isn't it? Hold on. Let me put it in the right spot instead of the wrong one. Okay, so it goes right here. Now, this line must go towards negative infinity, so it has to go left. And the slope is negative 1/3. So instead of going down and right, we go up and left. So it's headed off this direction. Now, the next one is the square root. You guys already told me, so it's going to look like this, or like this, or like this, or like that, depending on how it's reflected. This one's opening down because of the negative. But the nice part is they give us a start and a stop. So if we plug in negative 3 for our start, if you plug in negative 3, you get out 0. If we plug in 1, 1 plus 3 is 4, square root of 4 is 2. The opposite of that is negative 2. This one has a start and a stop. A start and a stop. And it goes like this. Whoop. Eyebrow down. Square root is opening down. Over 1 down 1, over 4 down 2. The last one is our parabola. Now, if we've got to graph the whole thing, we know the vertex is at 2, 2, right? But we don't get to do the whole thing. So let's figure out where the starting point is. If I plug in 1, 1 minus 2 is negative 1. Negative 1 squared is positive 1. And 1 plus 2 is 3. So it starts at 1, 3, and that's going to be an open circle. Open circle. Now, if we got to graph the whole thing, we knew that we would know the vertex is at 2, 2. So do you see that this is a little bit of the left side of the parabola, and then we get to keep going right. A moves for a parabola from the vertex are left 1 up 1, right 1 up 1. Left 2 up 4, but left 2 is outside of that restricted domain. So I can't go left 2, but I can go right 2 up 4. Okay. And that's it. That's all we have for today. So evaluating piecewise functions and graphing piecewise functions. Tomorrow, I'm going to give you the graph, and you're going to give me the function. We're going backwards. You get the picture, you come up with this. Yeah.